Okay, so here we go. Today we are going to talk about left and right endpoint approximations and midpoint approximations. Okay? So we're talking about area. All right? This entire week will be area. All right? We are really good at basic geometry area formulas, right?
No.
Yes.
More or less.
Okay? So many times there are curves that are quite geometric. Okay? Like this right here. Not a circle. Okay, looks like a parabola, right? We can't really use a circle to figure out the area. Can't really use it's not a geometric figure. Okay? But what we can do is we can use different simple geometric figures and add their areas up to approximate the area under a curve. Okay? Today we are going to work with rectangles. Tomorrow we're going to work with trapezoids. Okay? We're all excited.
It's a trap.
Okay. So what we're going to do, we're going to take a curve. What? How am I not plugged in?
I caught that on camera. You got it.
We can take a curve. Okay, if I'm going to find the area under a curve, when I talk about area under the curve, we're talking about from where the curve is back to the x-axis. Okay. We can split it up into intervals and make rectangles either using the right side, the left side, or the middle. Okay. So I'm going to go to. Mm-hmm. Okay, so here we have an equation 16 minus the quantity x minus 8 squared. So we're talking about a parabola. And right now I have red rectangles, 7 of them, that use the left endpoint for a rectangle. Okay? What I'm going to do though, I'm going to move this. What?
Or now they're 7.
You know what? There was 5.
Other 7.
Okay. So here's what left endpoint ones look like. Here are right endpoints. And then we could also use the middle. All right, so let's, here are the right and left together. Okay? Where they both have the same width for their rectangles. They're all consistent rectangles with the width. We're just using different heights. Notice how these go over our curve. We'll talk about that in a little bit. These go under our curve. Okay? There's not ever going to be a set number of rectangles we're going to use, but the more we have, the more accurate our area is going to be. Okay? Probably not going to give you a problem like that. Okay? They're probably going to look closer to something like this. Okay? If you were to guess, do you think in this picture the left, the right, or the midpoint is going to be more accurate? Midpoint? Okay. Well, we'll talk about that as we go. Okay. Now I want to talk about right, left, middle. Okay. The right side of each of these rectangles lies on the curve. Okay. The left side of each rectangle lies on the curve. The middle of each rectangle lies on the curve. Okay. That's what separates separates the difference between these three. Okay. So if I ask you for the area, you'll either have to decide or I will give you how many rectangles I want you to use. Okay? You will either have to determine or I will tell you use left, right, or middle endpoints. When I say determine, we'll talk about over approximating and under approximating. If I ask for an overestimate, you'll have to decide between right and left, depending on what the curve looks like. Okay? You're going to calculate the widths. Remember, all the widths are going to be the same. We're going to have consistent widths. But then each rectangle will probably have a different height. Okay? Then what you're going to do, you're going to take all of these areas and add them up, and that's your approximation. Okay? It's very, very geometric today. What?
Geometry.
Now, even if you disliked geometry, calculating the area of rectangles isn't bad, right?
How do you do that again?
Why not?
All right, are you ready?
No.
Okay, we're going to talk about one more thing before we actually get to an example. You need to understand when we're going to be over approximating or under approximating our area. Okay, and it will be different depending on the curve. Okay, so if you look at the difference in these two pictures, this top one, our rectangles are inscribed because our rectangles are inside of the curve. Okay, down in the second picture, our rectangles are circumscribed because we're sitting outside of our curve. Okay, now if we are under our curve, like in this first picture, we are going to be under approximating, okay, because you see these white spaces, we're not really getting the total area. Okay, we're going to be a little bit short because of those white spaces. Now down here in the second picture, when we have bits of rectangle outside of our curve, we're going to be over approximating because these little corners right here are outside of the curve, and that's really not area, that's underneath. Okay. Now, this picture has right endpoints and this picture has left endpoints. That does not mean all right endpoints are going to be an under approximation. When would right endpoints be an over approximation? Okay. If our graph increases, then our right endpoints are going to be an over approximation. The best thing you can do for yourself is draw a picture if you need to. Okay, so in my first example, we're going to do the left endpoints, the right endpoints, and then the midpoints. Okay, we're going to do all three for just one problem. So are we ready? Lindsay, are you good? Okay, Ashley. All right, so we're going to take the curve y equals x squared, and we're going to find the area underneath of it from 0 to 1. I'm going to tell you, well, if you were to pick how many rectangles, what would you maybe choose?
4.
4? 4 would be a good number. Okay. I can't remember what your homework does. I think your homework gives it to you. We're going to do n is 4. Okay. And we're going to do our left endpoints first. Okay. If n is 4, how wide are all of our rectangles? What? Okay. Our rectangles are going to have width of 1/4. To go from 0 to 1, we have 4 intervals, so they're each going to be 1/4 apart. Everyone okay with that? Okay. If we are using left endpoints, that means whatever's on our curve, that's the left of the rectangle. So, between 0 and 1/4, how high is our rectangle? 0. Between 0 and 1/2, our rectangle looks like this, doesn't it? Bear with me, please. How high is that rectangle? How do we determine how high that is? At this point right here, x is 1/4, which means y is what? 1/16. So the height of that rectangle is 1/16. Okay. Now, my rectangle between 1/2 and 3/4, okay, remember the left side has to lie on our curve. Okay, so since this is the coordinate 1/2, 1/4, our rectangle has height 1/4. Right?
Yeah.
Okay. And then between 3/4 and 1, remember the left side has to lie on the curve. And since this is the point 3/4, 9/16, that rectangle has height of 9/16 because the y is representing vertical, correct? Okay. So our area approximation, our first rectangle, what's our area? 0. Our second rectangle has width 1/4, and what's its height?
1/16. So 1/4.
Our third rectangle, width 1/4, what's its height? 1/4. Remember, the y represents height. Nope, 1/4 the width of this guy,
Oh, okay, yeah.
and 1/4 the height. Okay, and then our fourth rectangle has height has width 1/4. What's the height? 9/16. Okay. Now, since all of these rectangles have the same width, you could say that this is 1/4 times 0 plus 1/4, so plus 1/16 plus 1/4 plus 9/16. I don't care how you write it, just understand that these mean the same thing. What's our area?
It's 14/16 times 1/4. So it's going to be 14/64.
So 7/32. Okay. As a decimal, it's that, just for reference. Is this an over or under approximation? It's under because all of our rectangles are fitting under the curve.
Why is that considered like less?
Because if I color in all my rectangles, we still have this white space here that's technically area under the curve that we don't have any calculation for. Why is this left? Because our rectangle, the left side is sitting in the curve. Okay? So now we're going to go and we're going to do our right endpoint. Okay? We're still going to do n equals 4. So our rectangles are still going to have a width of 1/4. But this time, the right side is going to sit on the curve. So between 0 and 1/4, the right side will sit on the curve. Okay, and we decided that this coordinate right here was 1/4, 1/16. Right? Okay, between 1/4 and 1/2, the right side sits on the curve. And we decided that that was 1/2, 1/4. Between 1/2 and 3/4, the right side sits on the curve.
3/4, 7/16.
Okay, and between 3/4 and 1, we make the right side sit on the curve. 1/1. Yeah. Okay. So our area this rectangle is 1/4 by 1/16. This second rectangle is 1/4 by 1/4. This third rectangle is 1/4 by 9/16. And our last rectangle is 1/4 by 1. So what's our area? 30/64, so 15 32nds. Okay. As a decimal, it'd be approximated to 0.468. Okay. This is an over approximation. Okay. What we want is the area under the curve, which would be this right here, correct? But we found the area of all those rectangles, so we added just a little bit more to what that actual area is. Ready for midpoints? All right, let's do midpoints. N is still going to be equal to 4, which means our rectangle widths are still going to be 1/4. Okay. So between 0 and 1/4, the height is going to be calculated,
Right at the midpoint.
which is what?
1/8.
So at the midpoint of 1/8, that's how high our rectangle is. Okay. So I'm just going to remind myself that this is 1/8. What's the midpoint between 1/4 and 1/2? 3 what? 3/8. Okay, between a fourth and 3/4.
It's gonna be 5/8.
And between 3/4 and 1.
7/8.
Okay. I didn't write my coordinates because it's going to get a little squished in there. All right. And we've done this twice, so I think we have an idea of how we get the height. So this first rectangle, of course, it has width of 1/4. What's the height?
What's 1/64?
1/64.
Yeah.
Okay. Remember, we find the height by the y value. Since we have y equals x squared, we're just putting in x squared. All right. At 3/8, what's our height?
64.
Our third rectangle has height of,
25/64.
and our last rectangle has height of,
49. 40. Huh? That's weird. You know what I mean. That's weird.
anybody got a number for me?
Nope.
So you said? About 0.3. Yeah, something? 21. That's impressive. Good job. So as a decimal, Nolan, what did you say? Okay. As a decimal, that's what we have. I will tell you the actual area is 1/3. Next week, I will teach you how to find the actual area. Okay, right now we're just approximating. Okay? Now the midpoint is always going to be the closest of the three, and we're not going to say it's an over or under approximation. It could be either. Tara.
How do you determine which method you use?
Well, if I ask for an under or over approximation, you're going to pick between right or left depending on the curve. Otherwise, I will tell you probably which one I want you to use. Okay? But like I said, the midpoint is going to be closer than a right or left. And tomorrow we'll look at trapezoid, which is even closer. Okay? Any questions on the midpoint?
Is the midpoint kind of like the average of the lower and or upper? Like over and under? Or is it not?
What are they?
Well-
Calculator. 0.2 left.
You have 7:30 seconds and 15:30 seconds.
7:30 seconds.
And 15:30 seconds. Not quite. The x is going to be the average because it's in the middle, but since it's not linear, the y is not going to be an average. The heights aren't going to be an average.
The average is 34. 0.34.
Does that make sense? Okay. If it was linear, yes. Okay. All right. So I want to look at a couple problems where I'm asking for the upper and lower. Okay. So this time, let's see, what do we want to do first? Let's do the lower sum first.
Just lower than your approximation.
Lower means an under approximation. So for this picture, would we want right or left? We would want right. Now I'm asking between 0 and 2 with subintervals, with 4 subintervals. So how wide are my rectangles going to be?
Half.
1/2. Okay. So for this rectangle, the right is going to be on the curve. For this rectangle, the right They're supposed to be the same width. I apologize. Okay, the right side is on the curve. What? Anyway, this first awful rectangle right here. It has width of what? 1/2. And its height. What's the y? How do we find this y value right here? It's when x is what? When x is 1/2. So if y equals 6 minus x squared, what's our y value here?
5 3/4, so 23/4.
Okay. This rectangle has width of 1/2. Okay. Its height is calculated here when x is 1. So our height is 5. This third rectangle, of course, we have width of 1/2. Our height is calculated when x is
3.
okay.
3.
Thank you. This rectangle, its height is what?
2.
So what's our area? I will allow you to use your calculator.
38 plus 5 halves plus 1. So it's 5 halves. 20. So 58 eighths. 66 eighths. So boom. Wait.
You just need to
simplify it. 33/4.
Which is the same as what?
66 eighths.
8 point what?
8.25.
You did that.
Thank you. Okay. And this is our under approximation. Now let's look at our over approximation. I'm not sure why that's highlighted, but that's all right.
Let's just run with it.
Okay. So we're looking at left endpoints. Who wants to come draw me that picture?
No one does.
Yeah, no one does.
I actually think Megan. I said no one.
Oh, you told me to say that. Okay.
Why? I can't use blue.
I'm starting with here.
I like blue.
Oh, wait. Well, we're going from 0 until 2. Just kidding. Just kidding.
Pretend that's all the line. It's not probably.
It's okay. It's okay. Just go with it.
I heard live.
No,
Hopefully that wasn't the recording.
Say it louder. Hey, Allison. How you doing?
Great.
That's good.
oh,
Here's someone.
that's tough.
That'll work. Thank you. I'm just going to cancel this one. All right. Is everyone okay with her picture? Okay. Now, I saw that she started to begin on the right side and then she went back to the left side. When you're drawing your right hand endpoints, if it helps you to start on the right, there's nothing wrong with that. Okay? I think that's kind of what you had in mind, but didn't realize it was left and you went back to the left. Okay, so this rectangle right here has a width of 1/2. Its height comes from when x is 0, right? So its height is this. Our next rectangle comes from, our height comes from when x is 1/2.
So we already figured that out. It was 23/4. No, it wasn't. It was 23/4.
23/4. Sorry. Our third rectangle, its height comes from when x is 1. And what's our last height? What? Yes. 10.25.
Yep.
What's a fraction?
45/4.
Try again.
Okay. 41/4.
10 1/4. Right?
I just multiplied 10/25.
That's okay. All right. So this one is bigger than this one. Should be true, correct? Our actual area is 28/3. Okay, which is 9 1/3, right? So over approximation, under approximation. Not exactly halfway, but
Close.
maybe in the middle.
Pretty darn close.
If I had a guess.
If I had to guess.
All right. These problems right here deal with left and right. These problems right here deal with midpoint. Now, the instructions for 63 and 64 have a funny little summation formula. Just use your geometric pictures. Okay? Don't worry about the little summation formula. Yes.
If you take the left and right, you put the averages in. What is that? Is that
It's not going to be symbolic to the actual area. It'll be maybe a closer approximation, but it's not going to be, it's not going to give you the exact midpoint approximation. So, but it'll be close to the actual. It depends. It depends on the severity of the steepness of the curve. Okay.